Everyone, and for today's video I will be explaining what is transformation of random variables. So first and foremost, let's have first our objectives. So our first objective is to define what is transformation of variables, and second is to identify the methods of transformation of variables, and last one is to determine how the distribution of a random variable changes when the variable is transformed in a deterministic way. We will explore transformation of variables in this session, so which is important while learning probability. So we understand that data does not always arrive in an easily analyzed format. So before performing the analysis, we frequently have to alter the variables. Also, it can help us better study a distribution in several cases. So, variables distribution can be transformed from skew to normal by transforming it by bell shape, symmetric about its center. Let's dive into the discussion. So, when we say transform variables with discrete distribution, it is the probability density function of y can be estimated using simple probability rules when the transformed variable y has a discrete distribution. So assume that x has a discrete distribution with probability density function f on a countable set S. Then y has a discrete distribution with g as the probability density function given by g of y equals to sigma x as an element of r raised to the power of -1 and quantity y, and f of x equals to y and an element of t. As you can see in this proof, it is a transformation of a discrete probability distribution. So assume that x has a continuous distribution on a subset S subset equals to Rn with probability density function f, and that is t is countable. Then y has a discrete distribution with probability density function given by g of y equals to integral of r raised to the power of -1 y equals to fx dx. Y is element of t, and that's the proof of a continuous distribution S transformed by a discrete function R. S is going to t. Let's move on to the transform variables with continuous distribution. So when we say transform variables with continuous distribution, you will assume that x has a continuous distribution on a subset S. Subset is equals to Rn, and that y is equals to r quantity x of y has a continuous distribution on a subset T, subset equal to Rm. Suppose also that x has a known probability density function f. So in many cases, the probability density function of y can be found by first finding the distribution of function y using basic rules of probability, and then computing the appropriate derivatives of the distribution function. So this general method is referred to appropriately enough as the distribution function method. So suppose that y is a real valued. The distribution function g of y is given by g of y is equals to integral of r to the raised to the power of -1 quantity negative infinity of y f of x dx. Y is an element of r. So in this discrete case, the formula is not much help. So it is usually better to work each problem from scratch. So the main step is to write the event y equals to y is greater than equal y in terms of x, and then find the probability of this event using the probability density function of x. Let's have the kinds of transformations. There are two kinds of transformation, which is linear transformations and non-linear transformations. So when we say linear transformations, it is to keep linear relationship between variables intact. As a result, after a linear adjustment, the correlation between x and y remains unchanged. Examples of a linear transformation to a variable x would be multiplying x by a constant, second is dividing x by a constant, and the third one is adding a constant to x. When we say nonlinear transformation, it is the changes or increases or decreases of a linear relationship between variables. So thus, changes the correlation between variables. Example of a nonlinear transformation of variable, x can be taken as square root of x, log of x, power of x, and the reciprocal of x. So let's take an example. So these are the examples of transformation of variables. Let's explore more. So I have given an exercises here in my video, and you can answer it in your home. And that would be all. Thank you for watching.